Hello and welcome to the second session of our webinar series, Rethink How We Build. My name is Julia and I'm happy to moderate this discussion today jointly with my colleague Sonja. Sonja, if you would like to say hi.
Hi.
This is today the second webinar of our webinar series. We have invited international experts to discuss the topic of embodied carbon from different angles over the course of 3 weeks. Last week, we discussed what embodied carbon is, why it is important, how it can be measured, and how it can also be integrated into NDCs. And the webinar also discussed the successful case of public procurement standards for buildings in Finland. Today, our topic is sustainable building materials and recycling for a carbon neutral future. This whole webinar series is organized by the Implementing Office of the National Designated Entity Germany. Idi Germany is one of 161 focal points, which have been created in the framework of the technology mechanism of the United Nations Framework Convention on Climate Change, the UNFCCC. Our aim is to facilitate the introduction, use, and transfer of climate-related technologies worldwide. And the Idi Germany is hosted by the Federal Ministry for Economic Affairs and Energy, BMWI, on whose behalf also these webinars are organized. Before we start with our panelists, let me give you a little bit of context to the webinars. We're talking about the building sector, which is undergoing a significant transformation globally. Over half of the buildings that will stand in 2016 have not been built yet. Especially in Africa and in Asia, the number of new buildings will increase rapidly in the coming years. And this fast growth presents a challenge to meet the goals of the Paris Agreement. Hence, what we build today has severe consequences for our future emissions. This forces the buildings and construction sector to rethink building materials and practices. Emissions from the production of 5 basic industrial materials, namely steel, cement, plastic, and other chemicals, paper and aluminum account for 20% of global CO2 emissions, and the demand for these materials is only expected to increase as many countries around the world continue to industrialize. Research by the IPCC predicts that if developing countries expand their infrastructure to average current global emissions, the global construction sector alone will emit 470 billion tons of carbon dioxide by 2050. This is more than the remaining carbon budget to avoid dangerous climate change. Hence, we need to think and talk about alternative building materials and recycling. Regarding our webinar series, we want to encourage an open discussion. So our speakers will first provide some inputs, which is then followed by a panel discussion. You as a listener are muted, but you can type questions in the Q&A box, which you can see at the bottom of your screen. You can ask questions on a presentation or for a certain speaker or for the panel as a total. My colleague Sonja, who you just saw, will make sure that your questions will be brought into the webinar. And of course, you can also tweet about the event using the Twitter handle that you can see on the screen. And this meeting will be recorded and we will put this on the website on which you also registered for the event. Let's have a quick look back at last week's webinar, where we had speakers from GBPN, University of Stuttgart, Wuppertal Institute, and the Environmental Ministry of Finland joining us. And it was discussed, as mentioned before already, about embodied carbon. So the buildings and construction industry is responsible for nearly 40% of global emissions in 2019, of which 25% are embedded emissions and 10% are global energy-related emissions. And the sector also generates, for example, 55% of total waste in Germany. About 20 countries, as we've learned last week, have already established clear requirements for the calculation of embedded emissions for the approval of new buildings and also as a requirements for the public procurement standards. Vietnam, for example, which was presented, has a fast-growing construction sector and is undergoing a switch from traditional energy-intensive fired clay bricks to sustainable alternatives such as autoclaved concrete ACC, foam concrete, and concrete brick blocks, CDB. We also discussed using wood as an alternative material, which has significant advantages such as energy savings, improved recirculation, but of course, the sustainable supply of wood is crucial. Finland, which was also presented, is considering the entire life cycle of buildings in its regulations, including the carbon footprint and carbon handprint by making use of a national carbon data set. If you missed last week's discussion, have a look at our website. You can find there a link to YouTube, where you can see the full recording of this interesting discussion. Now we are looking forward to continue talking about this exciting topic with our panel today, which consists of Michael Büchel from the BMW, Matthias Mendonca Oliveira from the Idi Initiative, Matthias Tietze from C3, Matthias Höppner from Holcim, Jan Skocek from Heidelberg Cement, and Franc Kamugisha from Ecoplastile. Thank you to our speakers for joining us today, and we will start with a brief introduction by Michael Büchel from BMW. You have the floor.
Thank you, Julia, very much for this excellent introduction. I'm just struggling to restart my video, but now it's working, apparently. So we can start. Thank you very much. A good day and a warm welcome to all participants and spectators. Thank you very much for joining in. As a representative of the Federal Ministry for Economic Affairs and Energy, BMWI, which is hosting the national designated entity, the NDE of Germany, I'm pleased to open the second session of the NDE Germany webinar, Rethink How We Build. Through the webinar series Julia just already lined out, we are addressing the need to lower greenhouse gas emissions embedded in our building materials. In the first webinar, which was held last week, we discussed that the building and construction industry has a very high energy and resource consumption, and our experts highlighted the lack of data as a key concern to design appropriate mitigation and adaptation measures in the sector. As part of our activities under the NDE Germany, we're supporting the collaboration of critical sectors, countries, institutions, and companies for the mitigation of greenhouse gas emissions, meeting the targets of the Paris Agreement. Therefore, addressing greenhouse gas emissions in the industry, including the construction industry, is one of our core focus areas. For this, I'm very delighted to welcome our distinguished guests for today's webinar. First, this is Mateus Mendonca from the British Ministerial Department of Business, Energy and Industry, BICE, so my counterpart, more or less. Tietze is one of the initiators of the Industrial Decarbonization Initiative, IDI, of the Clean Energy Ministerial, CEM, and which is a major government initiative for driving down emissions of industrial products such as steel and cement. And we suppose it will have a significant impact on the further steel and cement market development. Germany is supporting and collaborating with IDI, which was officially launched in June 2021 at the CEM ministerial meeting, and is soliciting government commitments driving industrial decarbonization through, for example, green public procurement and regulations. IDI will announce updates commitments at the global climate talks in Glasgow, COP26, in a side event. Probably a side event later this year. I'm equally pleased that we have representatives from key industrial companies such as Holcim and Heidelberg Cement joining us for the discussion on a low carbon, zero carbon future, as well as from C3 Carbon Concrete Composite, who will present their research on a new material which can hopefully be a game changer for the industry. Let's see. Looking forward to hear more on that. And last but not least, I'm very happy that we have the CEO and founder of Ecoplastile from Uganda joining us today, discussing his experience with plastic recycling. As a follow-up to this event, BMW and the NDE Germany will seek to collaborate and further promote the transition of low-carbon industrial products, contributing to the efforts of IDDI and its network under the UNFCCC's technology mechanism. I'm looking forward to engaged discussion and the follow-up of the transition to zero-carbon solutions in the industrial sector and building sector globally. So no more words. Let's hear the experts talk. Thank you very much.
Thank you, Michael, for these opening remarks. And yeah, let's get right into the presentations of our experts. First, we will have Matthias Oliveira. He's a senior policy advisor to the UK Department for Business, Energy and Industrial Strategy Initiative. Mateus focuses on markets for low carbon industry and COP26. And in this capacity, he is also part of the Industrial Deep Decarbonization Initiative, which he's going to present today. Thank you for joining, Mateus, and the floor is yours.
Thank you very much, Julia. Thank you very much, Michelle. I'm just trying to open my video, which is currently blocked. All right, so maybe starting out. Yes, hi, hello, and thank you very much for the warm introductions to myself, and it's really a pleasure to be here, and thank you for inviting me. And I really want to quickly talk a little bit about demand side policies and what they can do for industrial decarbonization of steel and cement. And I also want to speak about what the UK and other countries such as Germany are doing in that space internationally, and how can coordinate our efforts in this space. Essentially, we know that technologies are available to decarbonize industrial materials, but they are expensive. For instance, we see that there are around 15 pilots, 15 industrial pilots globally that will switch fuel used in the production of steel, for instance. And but on the other hand, the price of hydrogen-based steel, for instance, can increase by up to 100%, according to recent research by the Energy Transitions Commission. So the bigger question is, how do we absorb the so-called green premium of these products once they start getting to the market? We do so by having policies that enable end users of steel and cement to secure markets for green materials. So that's why today I want to talk to you about the Idi initiative that Michelle already spoke a bit about. So I'll just quickly introduce the initiative. I'll talk about the main outputs of the initiative. I'll talk a little bit about the timelines that Michelle already helpfully spoke a little bit about. So the initiative is currently led by India and the UK, and has active membership participation from Germany, Canada, and the UAE. Our operational agent is UNIDO, and we have formal expressions of interest to join the initiative from 5 other countries. And we'll also discuss how the G7 can strengthen and support the initiative going forward through the Industrial Decarbonization Agenda, which was launched at the last leaders level G7 meeting. There are 3 main outcomes to the initiative. These will be framed as working groups. So at COP26, we'll launch 3 working groups. The first one working on data collection. So how can we effectively collect as governments embodied carbon data of our procurement projects? So we're not trying to reinvent the wheel here. We're just trying to systematize how we calculate, how we collect, how we make the calculations, what are the assumptions of these calculations, how we can compare these assumptions, how we can be transparent about these assumptions behind the embodied carbon calculations. The second working, and how we digitalize as well the collection process. And the second working group is on standards. So how do we define low carbon steel, low carbon cement? How can we compare different standards that will invariably emerge in industry in that space? And it will invariably emerge in different countries as well. And the third working group will be on green public procurement, and we'll look at how we can set targets for green public procurement, how we can, what is the optimal bid evaluation process, what is the optimal verification process. So this will be launched, all these 3 working groups will be launched at COP26, but bear in mind that we'll also want to launch a green procurement campaign at COP26 to bring in other governments and companies as well, wanting to set to make commitments on their procurement of these materials, of low carbon versions of these materials. So these are the 3 main outputs plus the campaign. And I will quickly talk about the timeline for this year. So we launched the initiative on the 1st of June, but we will have discussions with the private sector as well, the global private sector, on what they can do with their procurement as well, and how they can fit into the initiative, how they can apply similar procurement models that will be discussed among the governments. We are initially thinking of a roundtable at the end of August, beginning of September. This slide is a bit out of date here. And we will discuss with them what is in the realm of the possible for COP26, and we will have a CEO Ministerial one happening in October. We'll design the initiative and the target, a potential common target for procurement in the months of August to September. There is an example of a target there, but it could be something else. We're just like looking for feedback from stakeholders on this. But essentially trying to see what kind of embodied carbon reduction we can achieve by 2030 of our procurement. And then we will have as well some research being done, some policy briefs that will be publicized in August, September, and October. And of course, we will work to increase the membership of the initiative itself. So this is like a very quick summary of what is happening in terms of DDI, and I just put a slide there with the main contact points. So you have UNIDO, you have Rana, who is the lead contact for the initiative from the UN side. You can, of course, contact me if you're interested to know more about the initiative. I'm really glad to be working with this, be working on this with other governments, and I'm happy to see all the engagement that came from other governments on this. Important to note that this needs to be analyzed between developing countries and developed countries. That's why it's so good to see India so actively involved in this work. And we also have a website that I can share with you, and you can have more information there and how to contact us. Thank you.
Thank you very much, Mateus, for this very concise introduction to the IDDI. And it seems like it's going to be a very interesting second semester for you this year on the run-up to COP26. Sonja, do we already have questions from the audience on Mateus's presentation?
No direct questions yet.
No questions yet. So this is another shout out to our audience. You're very welcome to ask any questions that you might have, either to Mateus or to the other speakers directly on a presentation or generally on the topic. We're looking forward to receiving your questions in the Q&A box. But then let's move on to our second brief presentation, which will be given by Matthias Tietze from C3, the Carbon Composite EV. Matthias is a researcher at the Technical University in Dresden and responsible also for the commercial management at C3 Carbon Composite. The floor is yours, Matthias.
Okay, thank you. Thank you for the warm welcome. I want to start my presentation now. I hope it works. Yes, it works. So I would give you a short overview about our project C-Cube and especially the carbon reinforced concrete. First of all, something about the motivation. What is the motivation? To build with a new material combination in the building sector, and we think there are a lot of future challenges we have, and I have 4 of them on this slide. I will start with the left picture, very short. The urbanization, this is a problem. The world population is growing, especially in the cities, you know this. And so we need a construction material to save space, because in 2050 will live 6.5 billion people in cities. The second point is steel corrosion. The most used material in the building sector is steel reinforced concrete, but the steel in this construction method could be corrode, and the construction did not reach the lifespan we expected. Third point is the resource consumption. The building sector is responsible for up to 50% of the worldwide resource consumption. And also the last point, the CO2 pollution. You notice only the cement production is responsible for 6% of the worldwide CO2 pollution. So if we think about resources and climate change, so we have to think about also about the building sector. So next slide, if it works. Yeah, next slide. So we think we have not the solution, but we think we have a solution for the future challenges. This could be carbon reinforced concrete because it has essential advantages. We think you could, first thing is you could construct very slim, and so you have a lot of usable space in your building. The second point is the carbon fibers as a reinforcement or chemical inert. That means it do not corrode. Third point is the resource efficiency. What you see is a double T-beam, a comparison of a steel reinforcement double T-beam on the left side, and on the right side, a steel reinforced double T-beam. And you see we need 50% less material in comparison of the steel reinforced construction. And the fourth point is, so if we need less material, we need less energy to produce the products, and also we need less cement. So we could also reduce the CO2 pollution with this combination. And we say that carbon concrete or carbon reinforced concrete could be a mega trend for the building sector in the 21st century, because you could use it, or you could use this material combination in, I think, every part of the building sector, for example, for tunnels, for bridges, and also for sandwich constructions and facade elements, for residential buildings, precast elements, and so on, and also for the application curved constructions. I think it's very interesting for the architects. So, but I think it's not a vision, it's not an idea in the future. We think we are now with some applications in the market. We have a lot of national technical approvals. For example, a limitation for crack width, a strengthening system, a system for facade elements, also sandwich elements, and also for precast parking garage system. And so I think we are starting into the market now. So I would like to give you a short overview about the material, the carbon material, where it came from. Sorry, this one. Yes. Okay. What you see, I give you a short overview about the process of the production. We start with a PRN precursor. The raw material from that is crude oil. Now that's not so good, but maybe in the future it could be lignin or bio oil. So we start with this PRN precursor. You see it in this glass bottle, this white fiber, and then we use a process they call pyrolyze, and you see this glasses in the background. Yellow, orange, and purple. These are the steps where we go to the carbon fiber. And after them, we do a sizing process with this fiber, and then you get this fiber spool on the right side for different applications in the aircraft and the building sector and automotive and whatever you want. Next slide. Yes, next slide. What you see is the development of the volume and the price. We start in 1970s with a very high price. It was only used in space and military, but now the price is decreasing, and now we are up to 15 euros per kilogram, and now it's very interesting for the building sector. But the experts or someone who is familiar with the building industry, they know the price for 15 euros per kilogram is very high in comparison to steel reinforcements. There's only €1 per kilogram, but we don't have to compare the price per kilo. We have to compare the performance. And carbon has only a quarter of the density of the steel reinforcement and a 6 times higher tensile strength. So you have a cost factor from 15 and a performance factor from 24. So we say carbon reinforcements and carbon fiber in the building sector is comparable now to steel. The next slide shows our reinforcements, reinforcement types. On the left side, you see the grids. They are we have this with different mesh widths. Widths are very small for different applications. On the right side, you see the rebars, for example, for bridges and for other reinforcement applications. We have different coatings for that, a styrol coating for very flexible applications. You need it in the existing building sector, or you could use also epoxy for very stiff reinforcements. Next slide. We can use this this material for new buildings. What you see is a very slim facade element, only 2 centimeters thick. And also for existing buildings, this is a very interesting application. You can strengthen existing buildings with a very slim layer of carbon reinforced concrete. So I have for you a short example. On the left side, you see the application with a steel shotcrete, a steel reinforced shotcrete, and on the right side, a carbon reinforced shotcrete application on an existing building, on a roof, for example. And you need in the steel version 8.5 centimeters of concrete, and in the carbon reinforced fiber version only 1.2 centimeters with the same load capacity. And so we could say we save 80% in concrete material in this case. And now I would like to give you some information about our cube. The cube is our building, what is built in Dresden now. And I would give you short information about the wall development and the reducing of the construction space. We started on the left side with a conventional precast wall, and we developed this with the target we would like to reduce construction space from 10% up to 45%. And this is the new wall we use in Dresden in the cube building. It's only 24 centimeters thick with 2 concrete layers and also a high performance insulation layer. And I think this could be a good way to save resources. And not my last slide, but one of the last slides is a visualization from our twist elements. This is a part of the cube building. It shows walls. It shows a wall element and also a roof element, and all in between. It's a doubled curved shell in a multi-layer construction system with a load capacity layer and also a weather layer and also an insulation layer. we combine this and save in this combination up to 35 to 50% of concrete material. And my last slide is a visualization also from the cube building that will maybe finished in March 2022 in Dresden at the campus from the TU Dresden. And with this picture, I will thank you for your attention, and I'm happy to be here, and I hope we have a good discussion. Thank you.
Thank you very much, Matthias, for showing already, also for bringing the implementation example for the material. I think that's quite exciting to see that TU Dresden is going to be in an innovative building quite soon, at least parts of it. So thank you for that. Did our audience ask any questions, Sonja?
No questions at the moment. I'm sure they are waiting eagerly for the panel discussion.
Okay.
Let's see. So, okay, then we will continue with our next input, which will be given by our third speaker and second Matthias for today, Dr. Matthias Hutner. He is head of technical marketing at Holcim, Germany. We are very happy to have you here, and yeah, please go ahead. The floor is yours. We cannot see or hear you yet, Matthias.
Okay, yeah. So I start again.
Yes, please. Can you switch on your camera as well?
Yeah, I tried already.
Can you try again?
Okay.
There you are. Thanks.
Okay. So once again, thank you for the invitation, and hello to everybody. Good afternoon. And I would like to give you some short, brief information about construction material recycling. The motto is build more with less. And I would also like to change to the next slide. Now it's working. We just changed our name of the company group from Lafarge Holcim to Holcim recently. So the presentation is still in the old layout, but I changed Lafarge Holcim to Holcim. So some Holcim fast facts. We are one of the world's leading global building materials suppliers, and we are active in about 70 countries. We are also leading in the way of sustainable construction, one of the leading companies from our point of view. And we have the biggest research and development organization within the group, the Global R&D Center in France. And more than 50% of our R&D effort is in green construction, and we have also quite a lot of patents in this field. So some basic figures about what we are talking about. About 100 billion tons of materials are consumed yearly, and about 40% of this material, we just heard it could also be 50%, are used for housing and infrastructure, and only 8.6% of this material is recirculate, so recycled. And so we have a very big footprint with our industry in the field of consumption of materials. Circular economy improves our resource efficiency. This is the way we should look for. And this means that we reduce waste and keeping materials in use. And so we talk about change in the business models, which will replace the end-of-life concept with keeping material in use. Sorry. And we should stop extracting, stop wasting, optimize what we have, and reuse and recycle. And so, as I already mentioned, only less % of the materials are recycled today. And this has to be improved. And as we already heard today, this is also related to the consumption of materials and not only of the CO2 emissions. The demand is going to is expected to be doubled until 2060. So there's a big effort for us to change. And just Holcim is using 620 million tons of resources in 2019. And circular economy is a major global challenge, gaining traction as a key lever to reduce CO2 emissions as well. So circular economy can enable 40% reduction of CO2 emissions also in cement, plastics, steel, and aluminum industries. And the priorities for business that we can divert 9.5 billion tons of construction demolition waste from landfills. We can use waste as a resource. We can phase out fossil fuels by using alternative materials, and we go for low carbon and we look for low carbon alternatives. So what can we do? Our ambition is building a circular zero waste future and optimize our operations and recycling assisting waste towards building a world with less. So starting point is recycle waste into a resource, and we have the aim to recycle 100 million tons materials by 2030 and to close the construction loop with urban mining. And another focus is, and this is also the story we heard just before, to do more with less material by building with different designs, as we already saw with carbon concrete, and doing also using also digital solutions like 3D printing, and use market platforms which optimize the supply, and also using BIM, building information management, to maintain and rebuild existing constructions. So we are looking to build a zero waste future and to optimize our operations, raise awareness for zero waste and circular living. So we need to create an ecosystem, a new ecosystem, to further reduce virgin materials used and scale up value creation. This has these elements to maintain the existing structures and to restore, to recover and regenerate building materials from construction demolition waste at the end of their lifetime, and life cycle, and preserve natural resources instead. We have to repurpose. We will support our customers, our communities in repurposing their waste. We will aim to become fossil free. This is also a big goal we have, and we would like to be a partner in this field to create an ecosystem, inviting our customers, employees, suppliers, and communities to join this approach. So some elements from our business, which we already started. We have a project like ORIS. This is a system for operational and construction efficiency and sourcing database, and we go for reduction of CO2 emissions and resources. We reuse minerals and waste. This is done by our daughter company Geocycle in all the different countries, and in some countries we are already on a very, very high level of reusing materials for the production of building materials. We just started in the recycling business in Germany. We took over a company in recycling business and would very much like to improve this business. And by using the recycled materials, we would also design products that incorporate recycled materials. This means also in cement production and in concrete production. And I give you some examples for products we already have in the market in some countries. For example, this Holcim Susteno as a cement, for example, which contains of about 20% of recycled concrete material. This also saves about 20% of CO2 emissions, and also, of course, natural sourcing material. And this is the first use of a cement that contains the construction and demolition material in the cement as a cement component. And another example is the Ecopact R cement. Ecopact is a group of concrete products that are reduced in CO2 emissions, and this one is also containing recycling material, and so we can save about 45% of virgin materials and reduce the CO2 emissions by 50% maximum. And if you also use the Ecopact Zero, we have some local offsetting for the remaining CO2 emissions related to that product. And as I already said, we are also starting in the circular aggregate business, and we'll try to save as much virgin materials as possible. And yeah, we have already started in this business, and this will be the way the whole industry should go for less resource consumption in the future. So thank you. This is the end of my presentation. Thank you.
Thank you very much, Matthias, for this good overview of the circular economy concept of Holcim. That was quite interesting. Sonja, do we have questions to Matthias?
Now you should be able to hear me. Hi. Yes, we do have some questions from the audience, one directly to Matthias, referring to an earlier speaker. So it says, we have heard from Mateus Oliveira the ambition of the Idi Initiative to promote green public procurement. Do you see green public procurement as an effective tool for low carbon markets? And what are your recommendations on green public procurement?
Yes, from my point of view, to promote green public procurement is the right way. You can see this in the Swiss market, for example. The city of Zurich started with this approach where you only are allowed to deliver ready-mix concrete if you have recycled material in it. And there are also some big cities in Germany thinking this direction, and if based on the knowledge that sometimes the recycled materials and CO2 reduced materials are higher in costs, you need also higher prices, and without any direction this way, you can't get a market breakthrough, because people always look for cheap material. And so I think the promotion of green public procurement would be the right way to increase the amount of more ecological building materials.
Great. We have another question from the audience. It relates actually to the presentations of both Matthias So I think we will ask it now to Matthias Höppner, and then maybe we can later pick it up in the panel discussion. It says, is ductile a carbon reinforced concrete? Is carbon reinforced concrete more cement intensive? And how does it compare to standard concrete in terms of embodied CO2 for similar performance?
Maybe I give the answer for the first part of the question. Ductile is not basically a carbon reinforced concrete. It could be a carbon reinforced concrete, but it's basically an ultra high performance concrete. And we are just installing production facilities for the production of carbon reinforced facade elements or concrete elements in Oldenburg, in northwestern Germany. So we will go into the market with a standard product, and we will get the market introduction next year. But these elements are not basically based on ductile. Ductile is a ultra high performance concrete, as I said. And maybe the second part of the question could be answered by the Matthias with 2T.
Yeah, would you like to come in directly, Matthias Tietze?
Yes, I could. I come in. Okay, thank you for this question. And of course, it needs a little bit more. It's more cement intensive, but you need much less material in the full on the whole construction. So I think because we need more cement because we use high performance cements or high performance concrete. So we need a little bit more cement, but you have to compare it to the full material we need for a construction. And if you compare this, in summary, we need less material than a classical steel reinforced construction. This could be my short question.
Thank you. Sonja, do we have any other direct questions, or shall we move on?
No, I think we can move on now.
Great. Then I'm happy to introduce our next speaker, who is Jan Skocek, the R&D Program Manager of Carbonation Technologies at the Global R&D at Heidelberg Cement. Jan currently manages R&D projects on CO2 reduction by concrete recarbonation and is going to present us something on that. Welcome, Jan.
Thank you, Julia, and welcome everyone from my side. I'm trying to operate the presentation too. Yeah, so I would like to give you a short overview about one concrete example, how recycling and reduction of CO2 emissions can be joined together, because this is not as obvious as said, because normally recycling involves much more processing steps. It might involve more logistic, and normally the materials, the waste streams are much more scattered than the centralized production, as in case of virgin aggregates, case of cement, case of concrete. So the CO2 saving by recycling is not that obvious as it would seem on the first sight. As also partly commented by my preceding speakers, concrete is responsible, especially the cement is responsible for a significant amount of CO2 emissions, some 6 to 8% worldwide, depending how it's accounted. And the biggest challenge of cement and concrete is the part of the emissions which is coming from clinker production, the part which is coming from limestone. Because limestone, it's the raw material used to provide the calcium oxide, which is the reactive component of the clinker of the cement, and there is no alternative to calcium carbonate. And as a result, for every ton of clinker which we produce, we emit half a ton of CO2 emissions, and as mentioned, there is no substitute for this. There is also important financial aspect, because if we compare the revenues of different sectors per ton of CO2 emitted, we see that cement and concrete industry is in a really bad position, because the material is comparatively cheap compared to others, compared to steel, compared to carbon, as mentioned previously, it's several orders of magnitude difference. So the cement production is very sensitive to CO2 price, and also we need to look for abatement measures which are cheap. But contrary to other products, we have one big advantage, and that is that the main product of clinker production, the calcium oxide, doesn't disappear. It stays in the concrete, part of the concrete, for the entire service life and even during the demolition. It carbonates naturally, so it binds some of the CO2 back, as calcium carbonate is the stable form of calcium oxide. But still, even after decades of service life, most of the calcium oxide provided via cement to the concrete is still there as a non-carbonated material. And in our project, we are trying to recover this calcium oxide and reuse it, recycle it back to the production of clinker, cement, and concrete. So to do that, we need to do several technological steps. First of them is, as we call it, selective separation, which is kind of advanced concrete recycling, whose aim is to split the old demolished concrete into original constituents, into recycled aggregates and sand. And what is left is the fine fraction, which we call recycled concrete paste, RCP, where the hydrates are concentrated and also the calcium oxide. As we remove these hydrates from the aggregates and the sand, what we are receiving are very high grade recycled aggregates. They cannot be compared with the conventional ones. And as a result, they can fully replace 100% virgin materials, including the sand fraction, which is not possible with common technologies. And we can do that without sacrificing fresh concrete properties, as you see in the left graph, and also without sacrificing the strength of the concrete, as you see on the right graph. And this is not just for some low-grade concrete. This is valid for conventional structural concrete with 40-50 megapascal compressive strength. And this is also done without any adjustments to the mix design of the concrete. So one does not need more cement or more admixtures. This is simple one-to-one replacement of virgin materials by the recycled materials. So this is the key contribution to the circularity, to the preservance of natural resources. But the main CO2 saving is realized by the remaining fraction by the recycled concrete base. As mentioned, this is rich in calcium oxide and almost free of CO2. So we can use it to replace the limestone in the burning process of clinker, which directly reduces the CO2 emissions, as we don't need to decompose that much limestone into calcium oxide. But that's not the end of the story. There is even more effective way how to use this calcium oxide rich material. And this is in a technology which we call enforced carbonation and which we developed. And here we are utilizing the fact that the calcium oxide reacts with CO2. But as now we are not carbonating a big piece of concrete structure, thick wall, let's say, but a very fine powder. And we are not carbonating with the CO2 concentration as in the atmosphere 0.04%, but some 15 to 20%, which is the CO2 concentration in the kiln gases from clinker production. This carbonation reaction happens very quickly, and with the technological feasible time, we can fully carbonate this RCP, fully bind the original process emission from limestone decomposition. So in fact, this is a carbon capture technology based on recycled material. And that's not the end of the story, because as there is not only calcium oxide in the cement hydrates, but also silicon and alumina. These two materials, these two components, they got activated by the carbonation and turn into a reactive material, which can be used for cement production. So at the end, after the carbon capture, we take this carbonated RCP, we blend it with a freshly produced clinker, and we have a new generation of high quality cements for structural concrete application. And why we are developing this technology is that it promotes the circular economy. So we can fully recycle the concrete, all the fractions, aggregates, sand, cement, and also CO2, and not to use it for some secondary applications, but back to the original application, which is for us the structural concrete. Big advantage is also that such approach is independent of other industries, because concrete is produced in such huge quantities that it's very difficult to find other industries that could absorb our CO2 because of the high volumes, and also because of the relatively cheap prices of concrete compared to other materials. It's very challenging to find some sensible business models how to trade the CO2. And this technology is very cost competitive, because as you see, it's everything rather simple processes. There is no big energetical input. We don't need to supply any heat. Everything is simple mechanical treatment or moving mechanically of the materials. However, it's still R&D project, R&D work, so not all the technologies are available. The selective separation, advanced recycling, this is relatively mature. We have started last week a pilot installation close to Berlin. The enforced carbonation, this is fully new technology. It will still need several years to mature, but we still could do some full-scale trials in one of our cement plants, so we know it works. Now it's more the engineering task to develop the suitable installations to realize it in the cheapest possible way. And with that, I would like to thank you for your attention, and I will be happy to take your questions now or later in the panel discussion.
Thank you very much, Jan, for presenting this interesting technology and for making a glimpse into the future of cement production. Sonia, do we have questions to Jan's presentation?
Yes, we do have a direct question. What are the plans for applying the low carbon technologies globally? How can governments and industry support the widespread use of low carbon cement in developing countries?
Yeah, I can talk only for Heidelberg Cement. Our ambition is to be carbon neutral worldwide by 2050. And I see two possible ways how to speed up the deployment of low carbon technologies by governments. One is to promote buying the low carbon products directly by the governments, cities, and so on, because at least for the time being, they are more expensive, sometimes not by too much, but they are more expensive than the conventional products. And if the governments don't buy such products, then the private customers will also not buy them. And the second way how to promote this is to set up the proper accounting rules, that all the materials are judged equally, that the calculation framework is uniform, and also that they can push to set up rules and standards to avoid or block the high carbon intensive products out of the market. And then there will be naturally the low carbon materials will pop up, will be marketed.
Okay, thanks. No further questions from the audience at this point.
And thank you for the moment, Jan. And we will move on to our last input from Franc Kamugisha from Ecoplastile. Ecoplastile is a waste management, construction and social enterprise from Uganda. And Franc is in charge of the overall strategy, public and investor relations and strategic partnerships, as he is founder, director and CEO of the company. Happy to have you here.
Yeah, sure. Interesting. Just trying to turn on my video. Great, fantastic. Okay. Yeah. From my side, it's very exciting to be part of this conversation. And I would definitely dive deep to talk about Ecoplastile and how we are recycling plastics to make sustainable construction materials for the next generation. Ecoplastile is on a mission to transform post-consumer plastic waste and glass waste into polymer sand roofing tiles and plastic plumbers in Uganda. And this was next slide. This was inspired by my personal story, having grown up in a slum community. I dare witness their consequences of poor plastic disposal and the housing crisis affecting my own city. And with this disappointment, I launched Ecoplastile with my partners as a social enterprise that works with slum dwellers to collect plastics and transform these into very sustainable construction materials, with our flagship product being a roofing tile and plastic plumbers. And this one is solving 3 problems. We can move to the next slide. Now, first of all, in Kampala only, my city, over 51% of the plastic generated remains uncollected out of the 600 tons of plastic that is generated every day. And today, looking at the housing crisis, we have over 2.5 million housing deficit in Uganda. And this is growing at 200,000 units per annum. And looking on the other side, millions, especially of marginalized youth and women in our community, have no access to green jobs. And these are some of the three problems that inspired us to create Ecoplastile. And we have a solution. Moving to the next slide. So currently we are withdrawing over 28 tons of plastic waste per month, which we use to recycle and manufacture low-cost and sustainable building materials that replaces concrete and timber-made products. Our products are zero carbon, as in they replace materials made out of concrete. And like the previous speakers talked about the production of cement, which contributes over 6% of the global CO2 emissions. We're looking at reducing this kind of effect of climate change caused by the construction sector, but also creating green jobs, especially for the marginalized youth and women across the value chain, and along the way, creating income for them and enabling them to access critical services like health and other services that they cannot afford at this particular time. We can move to the next slide. So we have a very interesting model at Ecoplastile. First of all, we work with community collection centers who collect plastic and they bring to us at our factory, either directly or through agents, or they can use a mobile application to deliver these plastic to our factory. And at the factory, we do processing and manufacturing using chemical-free processes. We introduced a new technology that replaces chemical recycling by using beeswax, wax from bees, to replace the chemical processes, and as a way to speed up the reaction, the plastic extrusion process. And we manufacture roofing tiles that we sell to construction companies and real estate developers, working with our major channel partners, being the major hardware stores and sales outlets. We can move to the next slide. Oh, thank you so much. No. Sorry. Okay, great. Sorry for this. Okay, great. Fantastic. Sorry for the, oh my God. Okay. Can you move to the slide back, the back slide? Great, fantastic. Thank you. Yeah, sure. So our products majorly are used for roofing, because like I said, our flagship products are roofing tiles that you see in the picture, and they are used for roofing houses. They are 2 times more larger in size, light in weight compared to other roofing tiles on the market, and large in size, meaning that they consume less timber, which saves our forest on the other hand, but also save the cost of construction by reducing the amount of timbers that you're supposed to use for the roof. And the plastic lumbers are used for furniture as well as fencing. Our 3-year strategic plan is to, first of all, environmentally to withdraw over 5 million metric tons of waste from the environment and eliminate over 12.25 million kilograms of CO2 emissions. How does this come? For every ton of plastic that we withdraw from the environment, we are able to save an equivalent of 2.5 kilograms of CO2 emissions. So this is a huge saving to the environment. And through using our roofing tiles, we estimate that we'll be able to save an equivalent of 600 hectares of forest land by replacing other conventional roofing tiles on the market with our own roofing tiles. But also socially, because we are a social enterprise and we look at working with especially the marginalized communities, We aim at creating 2,000 jobs, especially for the marginalized youth and women across the plastic value chain, from those who collect plastic to sorting to our factory processing, and then look at sales and distribution and roofing itself. So all this value chain aims to create over 2,000 jobs, and along the way it will increase their earnings from $1 to $6 per day. The other interesting bit of Ecoplastile is that we recently launched Waste Insure, which is a digital platform that allows anyone anywhere in Kampala to exchange plastic waste for insurance cover. So instead of buying plastic, they give us plastic, and in turn we give them insurance points. Points which they can redeem to pay for insurance cover, like health services and paying for school fees and other consumables. And we target to have 100,000 beneficiaries on this scheme within the next 3 years. And economically, because our roofing tiles are, like I said, the other benefits of being light in weight and more larger in size and more durable with low cost, low maintenance costs in the long run, we estimate to reduce the cost of construction by over 30%, which is a huge saving to the construction sector. I just want to end with a quote: small acts guided by the UN global goals, when multiplied by millions of people, can transform this world. And think impact and be part of this solution. I thank you so much. I welcome any questions if you have them. Thank you.
Thank you very much, Frank, for sharing your story and the story of Ecoplastile. That's very inspiring. Sonja, is there a question to Frank from the audience?
We don't have any direct questions at the moment.
Okay, then I would say let's move ahead to our panel discussion. I would like to ask all speakers to switch on their cameras so that we can have you all on the stage. And Sonja, if you could stop the screen sharing. So thank you again for making this very interesting, for providing these very interesting inputs into our today's topic. And I would like to maybe start off with a broader question. We've seen that many solutions innovations are actually ready or almost market ready. So what do you think is hindering the uptake in the market? And maybe also thinking about policies for enabling environments, what do you think could be conducive to increase the uptake of more sustainable materials in the building market? Who would like to start?
Maybe I could start with a very short answer. It's first of all, it's maybe the missing technical approvals for new products. They have to be approved, and this takes a time, at least in Germany. And on the other hand, it's also the higher costs of processing and so on, which also are just a little bit hindering the quick access to the market. So, and the mindset is the mindset of the people, of the end users, is already existing to go for products like this, but also in the whole value chain, there has to be a feeling for the value added for the whole process, and also for the customers to use sustainable products in the building industry.
I see nodding. Yes, Mateus, please.
I just really want to echo what Matthias said and really insist on the point of already raised on procurement action, really building the regulatory framework that would encourage and change behavior of end users of these materials, who would then start absorbing that initial cost in the short term of these materials and enable the market to grow, and for these materials to reach scale, to be troubleshooted, and eventually the price would decrease, as we've seen with all the technologies emerging in the market as uncompetitive and then becoming very competitive over a longer period. And then we would not need the regulations anymore. But to get to that point, it is necessary to have the regulations in place and the new legislative framework.
Franc, please.
Sure. Thank you so much. I think in addition to the previous speakers, one of the biggest, I will give a perspective of the African continent and Uganda in particular with sustainable construction materials. I think one of the biggest challenges to quick access to the market is the perception. It's really not easy for us here in Uganda to convince people who are used to conversion of building materials to adjust and begin using new products on the market. So I think it's a big challenge here. And the other big challenge is frameworks to accessing approvals for these products so that they can be able to, they can be trusted in the market is also another challenge that I think it's hindering these solutions to get to the market as much as possible.
Yeah, maybe a question also to Matthias Tietze, because you're also working with a new material and struggling with the market uptake at the moment. Do you see similar issues as mentioned before?
Yes, of course, because it's the same like Matthias Hutner says, we need technical approvals and norms to get into the market, but this is a long way, especially in Germany and also in Europe. And so we go step by step with national technical approvals, for example, in Germany, and then we have examples for Europe and the other countries. And so we go further. And maybe in 3, 4, or 5 years, we are market ready or have maybe a D-norm or a standard. Now we have a big project that calls industrial standard carbon concrete, but this starts in 2022. And in this project, we connect the full value chain with and want to develop our own industrial standard for the next 3, 4, or 5 years, and want to go into the market and give a security to all users when they use our material combination.
And maybe also another question on what is hindering the market uptake. What is the financial dimension of this? So are the prices also hindering the uptake because they are new material is more cost intensive, or do people maybe also perceive certain elements as more cost intensive?
In my opinion, our research says we are not. It costs not more when you could scale your processes up, but now we are not in the scaling process. We are still in a process. We develop the material more and more and have the first applications. And when we could scale it up, then the price could be decreased. Yes, of course.
I also see Franc nodding. So the scaling probably is a big issue for the pricing.
Yeah, sure. Thank you so much. I think with the pricing, of course, in my opinion, is that yeah, when you look at the roofing tiles that we have on the market currently, like for our case, it's one roofing tile, of course, is more higher in terms of prices compared to these other products on the market. But in the whole process itself, the cost for construction for the person, because it's large in size compared to others, and so and in the long run, you don't have to maintain these roofing tiles like it is for these other roofing tiles on the market. But of course, the perception that it's the price is a little higher upfront, I think is an issue for the beginning. Yeah.
Thank you for sharing this. Sonja, I think we have questions from the audience, don't we?
Yes, we do. We have quite a number of questions. I want to start with one that was missed earlier. It goes to Matthias Tietze. And the question is, have you integrated the HVAC in the slabs as well?
HVAC means heating systems, or what this means? Okay. Yes, it's possible. You can use carbon reinforced concrete, the carbon fibers, as a heating system also, in walls or in slabs or whatever. You could combine it. We have also research on this, but it's not a market ready system. But you can integrate it, of course. Also, transport of data and also switches for light and so on. You can integrate in the everything electrical function in the carbon fiber grids.
Okay, I hope this question is answered. Then I have two questions to Frank from the audience. The first one is, can you elaborate on the challenges for your business? What does it take to replicate your business model in other countries, in, for example, African countries?
Yeah, sure. Thank you so much for that great question. Yeah, sure. One of the biggest challenge, of course, we've been facing is access to affordable financing in our country, because we've tried to reach out to different banks to get enough money to do large-scale production, which I could call commercial production, and it's still becoming a challenge. But the business model is really scalable because there's a huge problem of plastic waste across the African countries, and it doesn't require too much money in terms of. I mean, there's too much plastic waste. There are already infrastructure, quite a number of people doing plastic waste collection almost in every city. So the business model is really scalable. And I think for our case right now, we are focusing on scaling by distribution model, so that we can do production of roofing tiles in Uganda as the main factory, and then we can do distribution of the roofing tiles to other neighboring countries like Kenya, Rwanda, Tanzania, and South Sudan. But the model is really replicable in other countries.
Okay, and then we had another question for you. How are the roof panels fixed to stay on long term, also to withstand any thunderstorms? The weight alone seems to be insufficient for fixing.
Yeah, fantastic. That's a great question. We've actually made our roofing tiles to be in a way that they have double traps, so you can fix them actually very easily. They are easy to work with, especially when it comes to fixing on the rooftop. And the other thing is that they do not require the use of metallic aluminum sheets. So that one is also a cost reduction for the person doing the construction. And in terms of the capacity to withstand harsh weather, our production technology ensures that these roofing tiles are very strong enough, very durable in the first place, very durable, and you cannot break them, because we actually guarantee 0 breakages for these roofing tiles on delivery to the site. So you buy 1,000 roofing tiles from the factory, and you receive 1,000 tiles on the site, 0 breakages. So they are very durable and stronger to withstand any kind of harsh weather. I hope that answers the question.
Okay, and then we had another one. I think this one can go to all speakers. For educational institutions, universities, and colleges, for instance, how can net zero be achieved through building materials?
Yeah, I think this will use many different activities, or will need different activities. There's a basic formula that could be defined as reduce the clinker content in the cement, reduce the cement content in the concrete, and reduce the amount of concrete used for the erection of a building. This would be one formula, and then we should go for recycling of materials, and for alternative technologies like we heard from Matthias, Tietze and Franc. So just look for new ways and opportunities and be open for the new ways of construction.
Thank you. And then we also had a question directly to Mateus. Any ambitions or plans for extending the IDDI to Africa with strong future new construction activities?
Yes, definitely. Like I said in my presentation, it's crucial that the coalition of countries involves developing and developed countries from across all continents. In the initial stage of the coalition, we're focusing on clean energy ministerial members because the initiative is hosted by the Clean Energy Ministerial. So we'll be engaging South Africa on this, and we will, as I said, launch a procurement campaign at COP26, and we'll invite all countries in the world to join it. It would include African countries, and again, the design of the target needs to be appropriate for both a developed economy and a developing economy to commit to.
Okay, and I think there's one last question from the audience, question to the panel on low carbon cement. You mentioned the importance on green public procurement and uniform standards. What are recommendations for the development of these standards? Do they have established, or are there any existing standards which can be used?
I can start if it's okay. It is important that we take stock of what already exists and how we compare those things. One example is responsible steel standard is being developed at the moment, but again, it's very specific to one type of material, it's very specific to one part of the embodied carbon life cycle. So we need to take stock of other things that are happening, and we need to take stock as countries and as end users of what is the minimum level requirement for something to be considered a standard. And I say this because it is important, for instance, to have very clear assumptions, as I said in my presentation. So what is the system boundaries you're taking into account? You cannot start having whole life cycle assessments that involve offsetting that is not part of the project. So if we're just talking about a construction project in general, we cannot just assume that by building a certain building, we're going to avoid a certain type of cars being driven in a road, or a certain type of offsetting from speculative thinking. So again, it's important to have clear in mind the process for setting those system boundaries, those assumptions, and a clear system for how we define what is a standard, what would not be a standard. But again, it's something that it needs an international forum for this to happen. It needs a clear consultation process in many countries that will feed into this international process, and that's essentially what the IDDI is proposing to do. And I need to say as well that the working groups we mentioned, they have to deliver in the next 3 years. So they will only live on for 3 years, and they have to come up with final conclusions, final decisions, and all the members of the IDDI have to agree to it consensually and agree to implementing the conclusions of these guidelines.
Those were all questions from the audience. Thanks.
Great. Then I would like to ask another question from our side. So when we're thinking about the big picture, where would you see the biggest challenge when aiming at closing the construction loop, so achieving a fully circular building industry? Do you think this is possible, or will there always be challenges or gaps which we might not be able to fill?
From my point of view, there are many challenges, because there is not only one way how you can get the solution, but there are many different technologies which are needed, and which will also have to be developed. And there are also new standards like for building materials containing recycled materials, be it the way Franc does in Uganda, or be it new cement types containing recycled concrete material, for example. So there are many challenges in different fields we have to solve, and I think we just should start doing what is possible today, and be open for any solution that could be open. Another challenge would be, from my point of view, regarding the circular economy. There is, especially from the knowledge which I have from Germany, you have regulations for saving the environmental field. So meaning that materials that contain many maybe heavy metals or other constituents that you would like not to have in the environment, you are also not allowed to reuse in the new building materials. And maybe this could be a way to look for the incorporation and the safe incorporation of these kind of materials in the final product. Otherwise, it would be very complicated to reuse many materials that are byproducts, for example, from other industries.
Yeah, I can add to this. I fully agree what Matthias said. And also the question is what means full circularity. If we would like to aim to reuse old constructions back to for new constructions at 100%, this is not achievable, I think, because it doesn't make sense. It would not be economical. But I think what can be done is to fully avoid landfilling. So to use to find alternative use for different products which are of too low quality to be reused, because as mentioned by Matthias, standards are changing. So old materials which were in the construction 50 years ago cannot be used nowadays. Let's name just asbestos, which is known to everyone. So we cannot recycle. So 100% cannot be achieved, but landfilling can be avoided already now with current technologies. But the market is not yet ready, and the regulation is not yet ready for that.
Frank, I see your hand up.
Yeah, sure. Thank you so much. Just in addition to the previous speakers, I think, yeah, the policy is not yet ready for this whole kind of issues to be dealt with, and the market itself is not yet ready. But I think it's very important that the construction sector rethinks circularity. We have to rethink the way we do production and the end life of the products that we do produce. And for us at Ecoplastile, the case is that we are making sure that all our roofing tiles that we are making for now, we can recycle them at their end life. And that is one strategy we are putting in place. So I think the construction sector needs to rethink the way we do production and the end life of the products that we do produce moving forward. But there are all lots of challenges that we really cannot solve at one time. I think it's solving one problem at a time that will work moving forward. Thank you.
Thanks. Mateus.
If it's okay, I'd like to take the opportunity to ask some questions from my fellow panelists. One of the big questions we have as governments that concerns everyone is feasibility. So if we were to have a target for procurement in terms of reducing its embodied emissions, there's always a question of feasibility. And since we have a great ensemble of people representing suppliers here, so perhaps my question is more directed to Ian and Matthias, but as well the other Matthias. What is, assuming price is not an issue anymore, and your clients are willing to pay the green premium in the next 9 years, where would that take us? Where could that take us? What kind of percentage reduction in emissions could we see in a construction project or overall for the cement sector? So that's one question. I'd like to see if someone would like to have a go at it. And for Frank, I have a question for you specifically, which is, you talked about raising funds and looking for affordable finance as a way to scale up your business there in Uganda. My question is, what do you think would be the role of the state? What would be the role of the Ugandan government in that process to assist you? Would it be the case that having new regulations, new standards in Uganda on the construction sector that would enforce that they take into account performance levels, long-term assessments of carbon, would this make your business model stronger, your case on with lenders stronger? Would that be the case, you think? So my question to you and my question to the others.
Maybe we start with, yeah, do you want to go first, please?
So sorry. Okay, sure. I really go fast. Thank you so much for this great question. I think, yeah, sure. Like I said, of course, access to affordable financing is, I want to emphasize affordable financing. So we are accessing finances, but it's really very expensive to borrow in Uganda. But I think the countries, the government is trying to put efforts to make sure that they lower the interest rates for especially companies like us and other budding companies out there. But of course, like with government and policies, it really takes a long time. It's a process, and you really cannot think that the process will really come and as quick as possible to help you your business. Move forward. And I think the other thing is that normally, like what I'm saying is that the government normally leaves some of these things to the private sector. So I think we are now rethinking the way we can maybe work with big corporations like Holcim and other large corporations to make sure that we drive these kind of innovations. Because in most cases, the government also want to come when they see something very big. So you have to be at a stage where the government has no option but to come and join you and support you. And that is our strategy now. We're not looking at the government. We are looking at the government coming in at a point where they feel they have no option but to come and support us, since we are solving a large problem in the country.
Yep, I can perhaps take the first question regarding the feasibility of the decarbonization of cement. What is needed is a clear pathway what will happen in the future, because now everything is developing very fast and it's not fully clear if there will be the border carbon adjustment rule, how the situation will look like, the carbon prices in 10 years, 15 years perspective, because to build a cement plant which will be carbon neutral, it doesn't happen overnight. It's a process for at least 10 years to start developing the technologies, really building, realize it. But it's, I believe, possible. It will happen sooner or later if UK will set clear pathway, clear regulatory framework. It can happen in the UK as the first country. It will, of course, have some cost implications. The cost of cement might increase 2 to 3 times, is my personal guess. But it can be done. But it cannot be done overnight on a big scale. You can cherry pick some special materials, special circumstances. You can offset some small volume of your production to offer carbon neutral products nowadays. But to really decarbonize the complete sector, it needs clear pathway, and it will take more than a decade.
Any additions to that from one of the Matthias, who were also included in the question from Mateus?
Yeah, I think I could only say something about our technology. We're looking for the future scenario that we say the best way is to prolong the lifespan of the existing buildings and the existing constructions. So we say we don't want to, or we want to expect prolong the lifespan, and we could do it with a very less material. Especially, I said it before in the presentation, with the strengthening method, and we could save a lot of material in comparison to the classical way with shot concrete or shotcrete. And I think it could be a good way to think about this, about more to go to look at the existing things and how we could have a longer lifespan for that.
Okay, then thank you all. This was a very, very interesting discussion that we had. This is also why we ran a few minutes over. So thank you also to the audience, which is still with us and listening to your insightful answers. So a big thank you to the panel and for your input presentations. That was highly valuable. And yeah, thank you to everyone who listened in today. We hope that you will also join our discussion next week, where we will focus on policy environment for rapid sustainable transformation on the building sector. So we are looking at this whole issue from a bit more from policy angle. You can sign up on the website for the session. And yeah, we're looking forward to welcoming you then at the same time, so 1 o'clock Central European time on 20th of July. And with this, I wish you all a very nice day. Big thank you again to our panel. It was a very interesting discussion, and have a very good afternoon or evening wherever you are. Thanks. Bye-bye.
Bye.
Bye-bye.
Thank you very much. Bye.